In 2150, humanity finally did what it had dreamed of for centuries. It left the solar system in search of a new home. Our target was Proxima Centauri b, the closest known exoplanet to Earth, orbiting the red dwarf Proxima Centauri at a distance of just 4.24 light-years. Its mass is only slightly larger than Earth's, about 1.1 to 1.3 Earth masses, and its orbit passes through the so-called habitable zone, where temperatures allow liquid water to exist. Astronomers had debated for decades whether the planet had an atmosphere, water, or even the faintest hint of life, but there was no definitive answer. Some models suggested the planet could have a dense atmosphere capable of retaining heat and shielding the surface from cosmic radiation. Others warned that aggressive flares from the red dwarf might have long ago stripped away any gaseous envelope, leaving only a bare rocky sphere. Thus, the 2015 mission became a gamble for the entire species. Either we would find a new home there, or we would remain forever trapped in our own system. This was not just a flight, it was a leap into the unknown, where every day could be the last, and every discovery could change our understanding of life in the universe. To reach the planet within a single human lifetime, humanity created a hybrid spacecraft, a laser sail accelerator, and a fusion-powered interstellar transport. At launch from the outskirts of Pluto, giant ground orbital lasers accelerated a thin light sail to a fraction of the speed of light, after which the sail detached, and the fusion engine served as both brake and main energy source in interstellar space. The journey lasted 40 years. Part of the crew spent it in hibernation, an artificially slowed metabolism that reduced aging to nearly zero. Every 6 months, one of the watch officers would wake up to check system status, replace worn components, and ensure the ship hadn't drifted off course. Others, the watch crew, took turns maintaining the ship's systems, tracking micrometeorite threats, and correcting the trajectory, guided by the faint light of Proxima in the distant darkness. Over the years of travel, the crew learned to live in confined space, where every cubic meter mattered. Hydroponic farms provided fresh vegetables, and recycling systems processed water with 98% efficiency. The ship became their temporary world, where the first children of the interstellar era were born, a generation that had never seen Earth. These children grew up under artificial light, where day and night were merely entries in the lighting system's log, and Earth was a myth told by their elders. They learned to speak, read, and operate the ship's systems before they ever learned to walk under real planetary gravity. For them, the ship was not just transport, it was home, school, hospital, and the only universe they had ever known. After 40 years of travel, the ship entered the Alpha Centauri system, where Proxima, a dim red star, 18,000 times fainter than our Sun. Its habitable zone lies incredibly close to the star. Proxima b's orbit is only 0.048 astronomical units, roughly 20 times closer than the distance between Earth and the Sun. The planet completes one orbit around its star in just 11.2 Earth days. Because of this proximity, Proxima's gravity has almost certainly tidally locked the planet to the star, much like the Moon to Earth. This means one hemisphere of Proxima b is in eternal day, while the other is in endless night. The Alpha Centauri system is triple. Besides Proxima, there are two other stars, Alpha Centauri A and Alpha Centauri B, orbiting each other. From the surface of Proxima b, they appear as bright moons in the night sky, slowly changing their positions over the years. For the crew, who had spent their entire lives seeing only the ship's artificial lighting, this sight was shocking. 3 stars in one sky, one red and dim, the other 2 bright and distant, creating a surreal landscape. On the planet's night side, these moons provided enough light to see the silhouettes of mountains and glaciers without lamps. On the day side, their light was lost in Proxima's red glow, which remained unchanged for years. From space, Proxima b looked like a dark disk, one side bathed in thick red glow, the other drowning in lightless shadow. Between them lay a narrow transitional belt, the terminator, where day flows into night. It was there that climate models promised the most stable conditions. Reconnaissance probes launched from the ship confirmed the most important thing. The planet has a dense atmosphere, rich in nitrogen and carbon dioxide, with traces of water vapor. Temperatures on the day side near the terminator remained within ranges where liquid water is possible, roughly 0 to plus 30 degrees Celsius, depending on altitude and terrain. But then came the bad news. Proxima is an active red dwarf, regularly erupting in powerful flares that release deadly doses of ultraviolet and X-ray radiation. Stellar storms periodically strip away the upper layers of the atmosphere and can render the day side of the planet unsuitable for open life. So the colonists quickly realized, if they wanted to survive, they would have to build not futuristic cities under the open sky, but fortified settlements hidden from the heavens. Orbital scanners detected signs of atmospheric erosion, gas clouds slowly escaping into space under the impact of the stellar wind. This meant the planet was gradually losing its envelope, and each year made it slightly less habitable. The first landing modules descended into the region where the red line of dawn was forever frozen above the horizon, at latitudes where the eternal morning provided enough light and warmth, but not yet lethal radiation. There, the atmosphere acted like a blanket. Winds carried heat from the illuminated side to the night side, creating a band of relatively stable temperature about 30 degrees wide. Gravity was slightly stronger than Earth's, about 1.1 to 1.3 G. Every step was harder, and equipment exhausted muscles faster. Colonists stepped onto the surface in exoskeletons that unloaded joints and allowed them to work for hours, not minutes. The first structures were subsurface domes and tunnels carved beneath layers of soil that shielded against cosmic radiation and Proxima's flares. On the surface, only minimal infrastructure, solar farms, communication antennas, data collection systems, and automated robots. The landing was a trial for everyone. The denser atmosphere created stronger drag, and Proxima's red light made the horizon blurry, almost impossible for judging distances. The first steps on an alien planet were slow and cautious. Every movement required double concentration due to the unfamiliar gravity. The exoskeletons hummed, compensating for the weight, but muscles still ached from the strain in the first hours. The most important question was simple: is there water here? Orbital spectrometers had already hinted at ice on the night side and possible oceans or lakes closer to the terminator. Recon drones launched in arcs around the planet found the first evidence. In the craters of the dark side lay ice caps, and closer to the boundary between day and night, lakes of meltwater protected from direct radiation by clouds and the atmosphere. Colonists built a system of thermal wells which melted ice in deep soil layers. The obtained water was filtered, enriched with minerals, and fed into closed-loop life support systems, from drinking water to hydroponics. The atmosphere offered both advantage and threat at once. It had enough pressure that theoretically a human could walk in a lightened spacesuit, but the composition was far from Earth's. Too little oxygen, lots of CO2, high levels of variable radiation. Therefore, all open-air work was done in protective suits, and real life boiled beneath the surface, in domes with Earth-type controlled atmospheres. The first water samples showed traces of minerals unusual for Earth. sulfur and chlorine compounds that could be toxic in high concentrations. Filtration systems had to be tuned for months before the water became safe for drinking and irrigation. But when the first plants in the hydroponic modules produced green leaves, it became a symbol. They were not just surviving, they were beginning to live. Life on Proxima b was a constant balance between light and darkness. On the day side, there was no night, only an unchanging red sky through which time merged into one endless day. On the night side, cold and eternal stellar silence reigned, where temperatures could drop to extreme values and the surface was locked in ice. The colony was located right on the terminator, where the star always hung low above the horizon. Solar panels caught the weak red light, and thermoelectric generators harvested the temperature difference between the warm day side and the cold night side. People learned to live without the familiar cycle of day and night. Sleep and work cycles were maintained by artificial lighting in the domes, clocks, and strict schedules, but psychologically, the brain still rebelled against the eternal dawn outside the walls. Mission psychologists recorded new disorders: Terminator depression, claustrophobia against the open sky, and addiction to virtual models of earthly forests and oceans. In response, artificial parks were created inside the domes, rooms with holographic skies, cloud projections, and rain sounds modeled from Earth recordings. Here, people gathered after shifts to forget, if only for a few hours, that their real planet was a world of eternal dawn outside, where any walk without protection could end in death. The main threat to the colony was Proxima's stellar flares. In minutes, the star could eject into space a stream of charged particles many times stronger than Earth's solar storms. Early warning systems tracked the star's activity using orbital telescopes and magnetic sensors. As soon as a flare began, surface robots shut down, people retreated into deep radiation shelters, and autonomous systems switched the colony to energy-saving mode. Each flare could damage the upper layers of the atmosphere and reduce its thickness, making it easier for gases to escape into space. For the colony, this meant constant uncertainty. They could develop a civilization on a planet that was slowly losing its life-supporting envelope. Some flares were so powerful that Proxima's brightness increased 1,000-fold in mere seconds, releasing energy equivalent to millions of atomic bombs. The star's magnetic field churned, creating activity cycles lasting hundreds of days, during which flares became almost monthly events. Colonists learned to live by the alarm signal. When the siren wailed, they had less than 10 minutes to reach the shelters. Those who remained on the surface during a flare received lethal radiation doses, even through exoskeletons. So the rule was simple. Alarm means drop everything and run underground. One of the mission's main questions remained unchanged. Was life born on Proxima b under these extreme conditions? Probe robots explored lakes, soil, and ice in search of organic molecules and microorganisms capable of surviving under intense radiation. On Earth, bacteria were already known that could withstand radiation levels lethal to humans, so the chance of finding extremophiles on Proxima b was real. If the colony found even the most primitive forms of life, humanity faced a moral dilemma. Do we have the right to turn this planet into a copy of Earth, knowing we might destroy a unique biosphere that had evolved for billions of years? The first soil samples showed traces of complex organic compounds, amino acids that could theoretically be products of biological processes. But were they true signs of life, or just the result of chemical reactions under the planet's unusual conditions? This question divided the colonists into two camps. Some demanded immediate terraforming, others insisted on preserving the planet untouched. Debates lasted for years until new data revealed something unexpected. In water samples from the Terminator lakes, structures resembling cell membranes were found. This was the moment of truth. If this was truly life, then humanity stood at a crossroads, to become creators of a new civilization or its destroyers. In 2150, Proxima Centauri b became humanity's first step into the interstellar ocean. This was not an idyllic second Earth. Gravity pressed harder, the sky blazed with flares, and the atmosphere could begin to evaporate at any moment under the star's assault. But it was precisely in such conditions that humanity learned to survive. In the narrow strip between light and darkness, between safety and risk, between our old home and the future, we were only just beginning to build. And when the first antennas of long-range communication rose into the sky from the domes of Proxima b, the signal that headed back toward the sun carried with it just one simple message: we survived, and we are staying here. This signal traveled 4.24 years through the darkness of interstellar space before reaching Earth. When it was received, celebrations erupted on the planet. People went out into the streets, looked at the sky, and imagined that somewhere beyond their own system, their descendants were building a new world. But for the colonists on Proxima b, this was not an ending, but a beginning. Ahead lay decades of struggle, adaptation, and the birth of the first children who would never see Earth. They became a new kind of humanity, interstellar, resilient, ready to live where others would perish.